I am. Now,
Okay.
can you see the screen?
Yes, I can. Yeah, let me move the, I have the video here. Let me move that. Okay, good. Excellent. Thank you. Very good. Welcome, everyone. So today's talk is applications of AI, and AI stands for artificial intelligence in supply chain management, hype versus reality. So Ken and I have been talking about this for a while, almost, I would say 4 or 5 months, for about 4 or 5 months. And, as you all know, I think we are inundated by this virtual revolution, right? Almost all of our life has become virtual. Meetings, eating, parties, socialization, everything has become virtual. And you must have also, been inundated with the talk of all of this other stuff that invades the workplace today, including machine learning, artificial intelligence, neural networks, deep learning. And some of these things actually permeate our everyday life without us knowing that it's really there is some AI in it. And I think the most common form of AI that we probably are used to would be, I don't know if you say Alexa in the morning to check your weather, or hey Google to tell me the weather. And that's considered a form of AI because in fact you are working with a machine and you're talking to a machine. So really, we wanted to just talk about, what is the hype, what is the reality, particularly as it relates to artificial intelligence in supply chain management, and where are we today? So we can go to the next slide. So just, I think Ken already introduced us. So by way of introduction, I think a good number of people may know me, at least in this, because I've been associated with Apex for a number of years, almost 20 plus years. And I used to be president back in 2010, 2011, and now I'm being recycled back as president of a new chapter, so which is the Apex Massachusetts Minuteman chapter. And my firm, Valtitude, is specializes in supply chain management. So I would say this in terms of Ganesh and I, in the differences. My firm is in supply chain management consulting, and we dabble in AI, right? We just look at AI applications for our clients. And Ganesh actually specializes in AI and machine learning. Ganesh, you want to say a little bit about your practice?
Sure, Mark. Yeah. So we help organizations tell stories from data, use data science, machine learning, AI to identify the insights, and data storytelling to convert them into a format that is consumable so that some decision can happen based on that. So yeah.
Excellent, excellent. Thank you. So basically, I'm a practitioner looking at AI applications, and Ganesh is a specialist and guru in machine learning and AI, and he works across different industry verticals, providing use cases and applications. Okay, next slide, Ganesh. So in this talk, we're going to we're going to cover particularly the state of AI and ML today. And AI again is artificial intelligence, ML is machine learning, and talk a little bit about hype and just do a level set, right? What is hype and what is reality, and what's driving the craze. In fact, if you think about it, there is a whole bunch of money that's flooding the capital markets, right? It's all running into AI. So Tesla is going to be, it could pretty much be the most valuable company, overtaking Amazon probably in a few months. And it's all about the Tesla driving itself, right? Whether there is somebody in the car or not, right? So there is a lot of craze about AI, and really we want to talk about, okay, so what can AI really do, and what are the business applications in AI? So we'll talk a little bit about, generally, like, to see where AI is and what has been the history, and then talk specifically about industry applications, particularly in supply chain. I think that would be just very useful takeaway for all of us supply chain professionals. And then we'll just, like, towards the end, we'll just finish the presentation with, so what should we do as practitioners, professionals who are functional experts? How do we leverage this? How do we upskill ourselves in this trend of AI and ML? Should we just go and take an engineering degree again, or learn some things and understand what AI does, and so be prepared for it? So we'll talk about that as well. Okay, very good. So AI, has been around for a long time. Is not a cool new toy. Although the buzz has been quite a bit of buzz in the last few years, and in fact, I think it also goes through kind of a hype cycle as well. So if you think about it, we can say AI is probably as old. Can you? Yeah, as old as the Queen, right? So, basically, it has been around a long, long time. And I know we have seen movies, the Star Wars movies, and it has been around even older than the Star Wars movies. So, it's not anything new. It has been around, and it has been in and out, right? It gets really popular, it gets hyped up, and there's more capital coming into the realm of AI, and we really uncover more things and we make a lot of progress. And then it just kind of fades out and the progress stalls a little bit. But the one thing is for sure, we have made a lot of progress in AI, and AI is going to make things better. But let's find out how. Okay. So, one of the things that happens is the fear of AI, right? What comes to mind when you think of artificial intelligence? The most common thing is about people worry about their jobs being taken by robots, right? AI, does it mean end of jobs, end of humanity? In fact, you may have read in the papers in the last 6 months or so, Elon Musk, the CEO of Tesla, he thinks that AI would be the end of humanity, right? So he says that he has seen this and it's not really very comforting, and and AI robots could take over the world. That's something that he has mentioned a few times. He does say different things, but so the question is, will it take over the jobs? So you can look at different headlines in the papers. Does machine displace men in the long run, right? Unemployment will end, honeymoon with robots. A robot is after your job. And automation linked to jobless count. Automation might end most unskilled jobs in 10 years. So now, if you think about it, especially the first one, does machine displace men in the long run? It doesn't say people. So really, if you think about it, most of these headlines are not in the last 5 years or last 10 years. They're actually from the last century, right? In fact, the first title is from New York Times, 1940. So this fear has been with us for a long, long time, right? So will AI end jobs? Will it take our jobs, or will it end humanity? So it'll, like, the world will be populated by robots. So we'll see. We'll talk a little bit more. So one example that some of you may remember is back in the 90s when Deep Blue, which is the IBM version of AI in the 90s, it beat world chess champion Gary Kasparov. So it was a stunner in the second game of chess. Um, but then it went on to actually win the series 4-2. And again, a rematch, it again won at 3.5 by 2.5, right? So which means, there is the smartest guy, brilliant chess player, champion, world chess champion, was beaten by a machine. Now, interestingly, Deep Blue was an expensive experiment, a machine with highly paid team of IBM scientists to beat the sharpest mind in chess. But believe it or not, we have made a lot of progress. Very ordinary personal computers today can beat Deep Blue, right? So that's the type of progress we have made. So, AI has been there, but what is inside, what has actually powered AI? If you look at it, it's really kind of a variety of algorithms and the math, right? And you may have heard of the term predictive analytics, right? Predictive analytics is used, and I know it is commonly used now in supply chain applications, in demand forecasting, in sales and operations planning, and a variety of things, including fraud analytics and such. So really broadly, you have machine learning, clustering, predictive analytics, and then there are a variety of things going in there, statistics, smoothing, advanced regression models, probabilistic planning, which some of you may have heard of, neural networks, which is more common in machine learning and deep learning. But if you look at all of this, the math behind all of this is around at least 50 plus years, right? They have been around a long, long time. So, really the content, the spirit of AI, the spirit of machine learning and spirit of AI is really the math and the statistics. Now, obviously, the term analytics and predictive analytics is new, right? It has been, maybe, I've heard the term analytics maybe 10, 15 years ago, and predictive analytics in the last 10 years or so, right? We used to say analysis, we used to have analysts, but now we have analytics gurus, right? So the terminology has changed, but the underlying concept, the math is pretty old, has been there. We've made a lot of a lot of progress in this. Now, what has changed is the power of computing, right? That actually has changed. So, three things happened in the last 20 years. One is big data, right? So, which is the ability to have large amounts of data, collecting, storing the data, and archiving the data, and the ability to use and process large amounts of data. And the storage costs have come down as well, right? So one is the ability to collect, archive, and analyze and process large amounts of data. Because your iPhone actually now can store 264 GB worth of data, right? And that is probably 1,000 times more capacity than mainframe computers in the 60s. I may actually be understating the power of the storage. And secondly, the democratization of the cloud and the computational power, right? The computational power has gone up manyfold. And this computational power is easily available through the cloud. So I don't have to buy a supercomputer. I can buy shared time from Google Cloud or Amazon Cloud or Microsoft Cloud. I can say, I just want to run a little experiment, just crunches millions of observations, but I only need 10 minutes of the cloud time, right? So it's just like a few dollars, and I'm able to run that experiment. So these things have really made AI powerful, because now we can use all that advanced math concepts and really leverage them in business applications that involve a lot of data. Okay, so now what is the hype? Like, let's think about where the hype is, right? So one is to say AI can program itself to do more than what it's taught, right? So at the end of the day, you have powerful math, big data, and programming, right? That allows us to crunch and provide insights, right? Usable insights. But can AI really program itself to do more than what it's taught? And it's believed, and maybe someday it may be the case where where we wrote a set of programs, but the programs started writing more programs to control humans. But that is commonly believed today, that machines will take over because they can write code that would actually even increase their learning. And AI will take your job and eventually replace humans. That's another hype, right? And we'll talk more about it through the session. And third is, it has been, AI is sexy, right? Everywhere you look, if you say AI, you get a job. If you say AI, you are just thought of very highly. So should businesses try to adopt AI and machine learning regardless of cost? And I have seen this with some of our clients and some of the bigger companies that are looking to adopt anything that says AI or machine learning. Now, interestingly, this also could lead to a perverse result, because people say they have an AI algorithm or an AI platform, are able to sell their software even though it may be nothing to do with AI, right? So that this is important to kind of distinguish between the hype and what is real, right? AI has its benefits, and that's what we're going to talk about. But we also need to steer clear of what the hype is and where we could be tricked in. And finally, we think AI is easy to implement, right? AI takes time, it takes a lot of effort, and the most important thing is not just the infrastructure or the hardware, or the software or the programming. It also the use case, the appropriate use case, because otherwise, you would end up spending more money than what the return is on AI. And the real use for AI, there are lots of glamorous things about AI, right? But the real productivity happens with really boring, mundane applications that humans don't want to do, right? And that's where AI would be very helpful. Okay. So now it's over to Ganesh to talk about the craze and also like get into the industry applications. Ganesh.
Yeah. Thank you, Mark. Hello, everyone. So let's dive into the next session. What's really driving this craze? And let's also demystify some of the terminologies. What is AI? What is machine learning? We look at the conceptual explanation of these terminologies as well. So before that, a quick poll. I would like to understand the mix of audience for this session. So Ken, would you be able to launch the poll A? While you launch, let me talk through this. Yeah, the poll is up. So here's a question. What's your level of familiarity with AI? Are you new to AI? Have some conceptual understanding? Or do you have a technical understanding, the next level? Or you've worked in AI? Given the mix of audience and the different backgrounds, it'll be interesting to see this. So we'll give it a few seconds, and can whenever you see enough responses coming in, please close the poll and share the results with everyone. And this session particularly, we are trying to keep this simple. So there will be basic concepts which we'll be talking about in a very, very simple manner. And okay, here we have the results. Majority of people have some conceptual understanding. Great. And then the second category is new to AI, 22%. And then the third one is have a technical understanding. A small set of people who have worked in AI. Great. And this mix is useful to know. So then I think all of these, the examples and the content we're going to be covering, I'm sure all of you will find it very, very relevant. So what's really changed today, right? Mark touched upon this. He talked about the trends driving the AI revolution today, even though we have had expert systems for the last 70 plus years. Something has really changed now, and Mark talked about it. We have huge volumes of data, personal data, Internet of Things, sensor-driven data, transactions, business data. And we've also seen that all of it can be stored. Data is available, it can be stored, and there is processing power to compute and not just archive it away, but do something with the data. And software and programs are available to automate whatever we can do, make it repeatable, and make it scale. And with internet and cloud, we can make it available to people anywhere, wherever they are. So these are the 5 trends which are driving the revolution today, and why it's making AI look very, very different from what we saw in the 1960s or 70s. So when you have all of this data, how do you move from data to business decision making? So ultimately, that's the holy grail of businesses, right? So yes, we have data, we have fancy analytics, but how useful it is? Is it helping my users, my executives make decisions? So this is a continuum, and these are the different activities that you will have to do to move from data to decision making. You initially collect the data, store it, and transform it. So data in its raw format is either not clean or it's not in a useful structure. So you'll have to transform it. And once you do that, then you start looking at basic reports. We've had MIS reports, basic KPIs for many decades. But the real value of data comes in when you go beyond reporting, simple reporting, into advanced analytics. You get deeper insights from data. We'll look at the 4 different kinds of insights shortly. But when you go into deeper insights, that's where you start finding something unusual and particularly useful. Insights are not going to be useful if you don't make it consumable. So end users should be able to understand it. So that's where you bring in data visualization, storytelling with data, visual dashboards. All of these help with the consumption aspect. And finally, it has to link back to the business workflows and decisions. When you look at these different activities, they fall into different stages. Data engineering is the first stage, which this discipline has. It covers data collection, storage, and transformation. And data science takes you beyond reporting, and it has everything to do with insights and consumption. So when you talk about machine learning and AI, it falls squarely into the insights bucket, and it's not complete until you make it consumable. And finally, decision science is the third discipline, which actually takes data science beyond by bringing in aspects of managerial science, behavioral science, and it actually unlocks the decision-making ability. So you need all of these, and usually organizations take this journey left to right. They collect the data, they pursue data science, and then they try to move up into decision science. And by the way, decision science is a really new upcoming discipline, and it holds a lot of potential. Gartner says this is the next hottest thing for the next 10 years. So one other interesting thing is, as organizations move up left to right, they create a culture of data. When decision making by everyone is based on data, there's a culture of data. And at that stage, what happens is everyone starts looking for insights. Everyone demands better data, better quality data. So that is where you see this the arrow moving in the reverse direction. So one is a push direction to get there. And once you reach sufficient maturity, there is demand within the organization for data and insights. So it's a dream for most organizations to get to that state, because then you don't have to keep pushing it so much. People understand it and they ask for more of it. So this is the journey every organization takes. And today in this presentation, we will talk more about data science, specifically insights, since the focus of this presentation is machine learning and AI. And we'll talk about consumption as well. So insights and consumption, those two boxes are the ones we'll be getting deeper into. So let's demystify the terminologies, right? Artificial intelligence. So there are several disciplines within artificial intelligence. So we talked about expert systems, the first version of AI in the 1960s, robotics, speech processing, vision. The main purpose of AI is to make machines think and behave like humans. That is a very simple definition. And machine learning is a subset of AI. So machine learning has a set of programs which learn and mimic this behavior, mimic this ability of humans. So it's a software-driven discipline, which is a subset of AI. And there are different techniques in machine learning. And deep learning, which many of you would have heard, and a lot of people equate deep learning to AI, it's just one of the techniques. It is a subset of machine learning, and there are, again, several techniques within that. You can like supervised learning, unsupervised learning. It gets into more of the terminologies. But these are the three levels that you should understand. AI is the bigger bucket. Machine learning is a subset of it. Deep learning is even a smaller subset of it. So now we will talk about a conceptual explanation of machine learning and deep learning with very, very simple examples, so that when someone talks about it, you will be able to relate to it. So how does machine learning work, and how is it different from applications? So Mark talked about the myths, right? So one common myth I keep hearing is anything which does stuff automatically, people label it as AI. So if it has good logic and does stuff quickly, they say this is AI driven. So we have had technology driven solutions, technology programs, software applications for a while. These are programs that solve the problem. You have to encode the logic very, very diligently. And then they do a great job. We've had these for 20, 30, 40 years. But they do the job the same way, whether they're doing it the first time or the millionth time, they do it the same way. There's no difference. Whereas when you have programs that learn how to solve the problem, you don't have to teach all the logic, but you use different approaches. Perhaps you can teach them by examples. When you teach them by examples, when you keep showing newer examples, it learns new logic. Then it starts doing things better. So the difference between the 10th and even the 20th time, there could be a big change when it comes to machine learning programs, because they learn how to solve the problem. So for instance, how do you go about doing this, right? So if you have known input and you have some data which you already have, and you know what is the outcome. So you show both of it to the machine. You say, this is the input, this is the outcome, and let the machine see both of it and say, now machine, you go and figure out how to arrive at the outcome when a new input is provided. So it figures out this connection between the left-hand side and the right-hand side, so that when it sees a new input, which it has never seen earlier, it's able to come with a desired outcome. A simple example. So here's the stock price of Apple. So for instance, we have taken the last many weeks of Apple stock prices, and we train a machine to say that if these are the prices for 100 days, the 101st day price is this. And then you take the next 100 days, and you do this multiple times. So all of this, you take the historical prices, show it to the machine. And then you say, you've seen the price until today. Today is about $123. What is likely to be the price tomorrow? The unknown state. So for instance, if it says $131, then you go out and buy that. And by the way, hope we have these financial disclaimers because I don't want to get into trouble. This is just an example. So this is how it works. This is an example of supervised learning. You show known input, known outcomes, and then let the machine figure it out. So how does deep learning work? So this is how most of the machine learning techniques work, right? So deep learning algorithms, we saw that it is a subset of machine learning, and they're particularly good with unstructured data, with text, images, video. They work on numbers as well, but they are particularly good at these unstructured forms of data. How do they work? They are inspired by the way we humans learn. For example, if I teach my 6-year-old daughter, I show her a series of pictures of animals, and I repeat the names of the animals over and over again. For instance, I say this is a name, this is an elephant, this is a rhino, and so on. So the next time when she sees this animal anywhere as a toy on the billboard or in the forest, she's able to instantly recognize it. I did not teach her by the different parts of the body, like the tusk, trunk, and ear. I just taught her in totality, and she was able to grasp it. And in terms of the different variations of the elephant, she's able to get it. So that's how smart the human brain is. There are deep neurons interconnected, and they work brilliantly. So neural networks, which is the technique behind deep learning, it's actually imitating this kind of a deeply connected neural networks. So it imitates this structure. And that's how, when you have, for instance, if you're unlocking your iPhone with face detection, you're using a form of deep learning. Because you show initial set of pictures. When you set up your iPhone, you take a set of pictures and you show in different angles, different lightings. And all of that is the first state we looked at: known input, known outcome. So you're showing the pictures and you're saying it is you. And then when you, on a particular day, if you open it and then start unlocking the device, it is able to use that learning and detect you on a completely new day. Even if you've grown a little bit of a beard, or if your hair looks a little different, it's able to recognize that. So that's how deep learning works. So this is an intuition behind machine learning and deep learning. So that was the second section. We talked about the basics and the terminologies. So now let's talk about the industry applications, machine learning and AI in supply chain. So before we get into this, again, another quick poll. Has your organization adopted AI and ML? Kenneth can launch poll B. So has your organization adopted any of these techniques? Options are: you're not considering it yet, or actively evaluating these, or you're running some pilots. A lot of organizations start with pilots. The next stage is you have gone beyond pilots. You're using some solutions in production, but not too many. And the final one is you're mature and you have many solutions in use. If anyone falls into the last category, probably at the end of the session, we'll let you speak and share some of your learnings. And for all others, it'll be useful to see which stage you are in. So whenever we have enough responses, let's close. And when we talk about the application, so in this section, I will be talking about 4 specific applications, and Mark will be covering overview of the ecosystem. So I see the results here. Majority of the people aren't considering it yet. So then this session would be great. I hope that you're convinced by the end of the session to consider and evaluate AI and ML solutions. And the second category is actually using a few AI ML solutions in production, 23%. And the third one is running some pilots. Okay, interesting. So now let me hand it over to Mark to talk about AI in supply chain.
So can you just click one more time? Can you hear me?
Yes.
Okay, good. All right, very good. So based on what we have seen and what we have done, AI applications are still new in supply chain, but really with the advent of big data, companies are using, IoT is another phenomenon, right? IoT is Internet of Things. So the ability for things to be connected, like the connected world, and that is able to communicate information real time, right? because they are all connected devices. There are many examples of this, especially physically unsafe places where you could have installed devices, high temperatures where humans cannot walk in, those type of things. A good example would be like a railroad company installed these IoT devices on train tracks, just to kind of rail tracks so that they can evaluate if there is a risk in the rail wheels. So basically, to see if there are any cracks in there, so that humans don't have to inspect them, but as the rails, as the trains run on the rails, they would automatically send signals real time, right? So there is a lot of data coming in here, right? So big data plus machine learning, which we talked about, the ability to use computational algorithms and really using this for predictive planning. And so through this, we could do a variety of things, right? Things that we were doing in terms of aggregate planning. And obviously, it is not going to replace aggregate planning for supply chain. We would still be doing aggregate planning, still be doing SNOP, but then you still have the visibility to look at the granular level to see, you may have heard of the term real-time SNOP, right? So ability to look at out of stock at the store level and ability to do demand sensing, the ability to look at trade promotions. There are tons of promotions, thousands of promotions running, real time, and understanding what type of lift these promotions create and what is the potential for an out of stock or capacity issue because because of an unexpected surge by these promotions, right? And then the systems also are able to adapt themselves, through this process, through what is called as cognitive learning. So you do have systems and models that can continuously adapt themselves. So that is actually the power of AI in supply chain. Let's move to next slide. Thanks. Okay. So here is a specific application for integrated business planning, where if you think about today, right, systems integrated business planning is, we have all heard of sales and operations planning. Integrated business planning is an evolution over sales and operations planning. And still aggregate planning, you are just doing demand supply balancing and solve the problems so that you have a better, well-run supply chain that is able to anticipate supply risks, capacity issues over the long run. At the same time, demand risks as well over the long run, so you can proactively plan. So that is the end concept that most of supply chain professionals exposed to SNOP would be aware of, right? But then, if you think about it, if you connect it end to end, really this SNOP problem originates from the customer, right? It starts from the trade promotions, point of sale data, and this is all massive amounts of data. And then, as I talked about in the previous screen about inventory, shelf life issues. So especially if it comes to perishable supply chains, right? Shelf life becomes very important, and more so now. We talk about cold chains, right? Especially the vaccine supply chain. Now we have heard that Pfizer's COVID vaccine needs a minus 94 degrees, minus 94 degrees F to store the vaccines and transport them, right? So these are all real challenges, and you need to be like plugged in terms of the data coming in, right? And obviously, a human cannot look into this, and then monitor this real time. But you need to have a system that is able to incorporate end to end, and the ability to sense it and flag appropriately when there is a breakdown. Because I've heard this as a common problem in cold chains, where you have drugs transported from, say, the US to to China, or US to, say, Middle East, and then sometimes it may be left unattended in the Dubai airport in the tarmac, right? And when the heat could touch about 110 degrees, the temperature could touch 110 degrees, right? So these are all potential challenges, when it comes to the supply chain that's integrated throughout the globe, right? So that's where, if you look at it here, the machine learning gives rise to AI-driven planning and predictive planning, and that helps us do a better way to do integrated business planning and also to real-time demand sensing. And finally, we also want to be able to collaborate with the customer and the suppliers. And you may have a multi-plant, multi-warehouse dynamics. Now, if you have challenges, let's say that through predictive planning, you are sensing some type of a capacity issue or a shortage issue down in the supply, then that has to be communicated back to demand to see proactively what we could do. So all of these things, especially when you talk about real-time S&OP, I think that is really possible with an AI-driven application. So now what we're going to do, we're going to talk about specific use cases in the supply chain that fundamentally kind of looks at this model, but a variety of different use cases that are applicable, where AI has done, AI would make a lot of progress, or AI would be very beneficial. Ganesh.
Yeah, thank you, Mark. So let's talk about the specific business applications, right? So before that, I would like to talk about the different levels of maturity. Where does AI and ML fit in, and what are the different kinds of insights? So one, we start with descriptive insights. That's the lowest level to find out what's happening. Look at last week. What is a simple summary? How are my vendors performing? Diagnostic is getting into the next level to find out. You ask the why question. Why is something happening? Why is a particular event happening? Business analysis, you get into statistics to validate, check statistical significance, and find out the reason. For instance, where are my goods stuck? So if you have a supply chain network, try to find out where is the problem happening. Predictive is a forward-looking one. You start looking into the future and you ask the question, what will happen in the future? This is where machine learning and AI is particularly helpful. While there are some examples of machine learning in the other categories, but predictive is really the case where both ML and AI are very, very useful. For instance, you can say, what will be my sales next month? Finally, prescriptive analytics is where you identify not just what will happen, but also you give a recommendation on what has to be done, which is why it is more powerful. You bridge that gap, again, ML AI with recommendations. For instance, what actions should you take? If you're running a survey, what actions should you take to convert your detractors into promoters? So these are the different 4 levels, and each of the examples we'll talk about, they fall into one of these. And also we will be looking at a mix of visual analytics, like visual analytics fall into descriptive and diagnostic, and some machine learning optimization and some AI examples. So the first example is this. So there is a European brewery which wanted to identify their purchase patterns. And they had different plans, and each of these plant managers had a different way of onboarding vendors and placing orders. So there was a lot of variation within the organization. So this firm wanted to look at each of the plans and identify, one, is there a way to consolidate vendors and orders, a common problem? And also find out if there are some unusual things, some clear deviations. So for this descriptive analysis, right, the first level we looked at, that is useful. For example, if you look at this one, so this visual application, it's a demo. I'll quickly walk through how it works. So you have the different items here. So this is an anonymized one. So you have concrete gloves, and you have different items across. And for each of it, you have the spend and the number of vendors and the orders, number of orders placed per week. So you would like to minimize the number of vendors in each of the plans and for the categories. So that is the intent. And once you see this on the left-hand side, you expand one of those items and go and find out what is the purchase distribution for that. So here's how it works. Right? So you're looking at the different vendors and orders, the patterns. And on the right-hand side, when you look at it, the way to read this is each of these bubbles, each of these rows are plants, and each of these bubbles are weeks. So the size of the bubble is the spend, and the color is the number of vendors. You can see that when you hover over this, some weeks it shows the number of orders and vendors. So this way, where I can check and see there are some plans where they're using many vendors. You see those yellow bubbles. Whereas when you scroll down, you can see plant 126. This is very different from all other plants. So they have extremely high number of vendors. So you see the yellow and red, which means that going by this legend, they have 10 to 20 vendors being used in that particular plant. So that clearly needs immediate attention. So that's how you check all of this with visual inspection. You're able to find out those anomalies and then make a decision. So this is a great starting point to discover patterns and take some quick decisions with descriptive visual analytics. So the second example is from supply chain and logistics bottleneck. So there's a large US retailer who is tracking the movement of goods from the manufacturers down to the stores. And they wanted to find out where these items are getting stuck. Look at the value of items and also look at the aging of items in each of those hops. So in this case, we're looking at diagnostic analytics, trying to find out where do I have problem, why do I have a problem. So here's how it works. So this visual, the way to read this is you have the goods moving from the vendor, the manufacturer or the vendor, to the store on the right-hand side. So it goes through several points, the collection point, cargo hub, warehouse, distribution center. So when it goes through these different levels, you have those connecting lines. The size of the line is the value, and the color is the aging. So if you have anything in red or orange, it means it's taking a lot of time. And anything which is thick versus thin, there's a high value goods in transit here compared to this portion. So now when you have this, how do you use this and how do you make your decision, right? How do you find out where is it getting stuck? So in this interactive application, you will be able to look at each of these connections, hover over it, it'll tell you the value. And as let me pause here, as I hover over it, it is showing me the value, and it is showing me that anything for this collection point C2, these two are problem areas from collection point to C2 to cargo hub 2. And when it is any item which is coming from trader vendor 1, so these probably need attention. And this is the value of goods stuck. And when I'm hovering over this, you notice this here, the table filters down to all of these. So this way you can inspect the problem areas and then find it. The next thing is I can filter it by value. I can filter it by a certain value, anything above a threshold value, and anything aging more than say 0.75 days or maybe 1.5 days. So now you can see that these are really the three links I need to inspect amongst the entire network, amongst all the items and all the vendors. These three are my problem areas. And when I hover over it, I get the items and I can go and make a decision or probably call the person and find out what action I need to take. So this is an example of how diagnostic analytics, here we are not using machine learning, no AI, but this is asking those deeper questions in terms of where is it getting stuck. And the next level of optimization is trying to find out, you can extend this into a forward-looking scenario to say, next week, if I have so many goods in transit, where will they get stuck? Then you bring in machine learning and AI into the same use case and say that, predict and tell me what should I do to avoid that issue next week. So that's how you bring it back into the workflow. So this is a second example. In case any of you have any questions at any time, do drop in chat or you can unmute and ask. Otherwise, at the end of the section, we'll pause for questions. So the next example, the third one is tackling, again, logistics, but specifically the challenge was for a global airline. They wanted to identify what was causing delay in cargo handling. So there are goods arriving at the airport, and from the time it arrives in the airport till the time they move it to the warehouse, the turnaround time in movement is something they're trying to optimize. And they want to identify what are the potential factors which could delay this movement, and what actions should they take? What is the recommendation? So now we are getting into the third level, not just find out what happened, which is diagnostics, but also tell me if I have to take a certain action, can you model some scenarios and say what corrective action I should take? How will it help me in the future? That's why it's getting into the predictive machine learning kind of a zone. Let's see how this works. So now we are looking at 4 factors. It could be the shift of the day, which is causing a delay, perhaps morning shift or night shift takes time. It could be the day of the week. Some day are they staffed enough? And could it be the product category? Some categories are they causing this challenge? Or is it something to do with part shipment? So now the color of these boxes is based on the turnaround time. Anything which is 1.5 hours or lesser, which is the SLA, is green. Over that is orange to red. And so let's see what happens right now. I want to see the shifts. Night shift looks green, which means that night shift is doing relatively better. Morning seems to be slightly orangish. Evening is somewhere in between. So when I hover over it, it is telling me the SLA as well. Morning is 1.76 hours. Now, I want to look at Friday mornings, because Friday mornings seems to, both of these, this connection seems to have some issues. When I click this, it opens up the connection. So Friday mornings is this connection. And then you have Monday mornings is this connection. Even the connecting lines are colored. So anything which is red or orange needs my attention. So I see that Friday mornings are bad, and Friday mornings for ZDH, which is a fragile category, takes a lot of time. And anything which is any fragile item which is part shipped, less than 20% shipment, takes more time. That's the bottommost layer. So now I get this insight, right? So I found it out. The next step is, what should I do? So now this is where we get into the optimization zone, right? So firstly, let me pause here. Firstly, we have opened up many of those paths which can be traversed. And we have filtered it for anything which is recovery time more than 1.74 hours. We've just done a simple filter. Now I have 5 trained staff. If I increase the number of staff from 5 to 6 or 7, will it make a difference? How will it change the turnaround times? That's what we're going to see. When we change this, it is going to kick off machine learning in the back end, and it runs an optimization algorithm to find out what is the expected turnaround times. So now it's 6 and now it's 7. So if you see this, let me pause when you were at 7. So when you move it to 7, you can see that most of these flows have turned green. So these have been taken care of. There are a few which are still orange. Now you go back and decide whether this is good enough for those items for that particular day or for a particular customer. And you, based on that, you do it. And in the actual implementation, there were many more factors, because beyond these 4, there could be other factors. And there were other items like forklifts and many other resources which you could play around with, not just the trained staff. So this is how you bring in machine learning, optimization, and predictive analytics into this. So now the 4th example, the final one, this is using AI, this is using deep learning. And the problem here is contract review. So this is a challenge for most organizations. There are hundreds of thousands of contracts every company signs up. And review of these contracts for risky clauses is a tough job. One, the volume of contracts, the number of contracts is very high. And many of these contracts have deliberate verbosity at times. And number 3, it is the manual effort, manually scanning through it. It can be error prone. And it could lead to fatigue, and it can be error prone. So this is where we can bring in a solution like AI to automate this process to a greater extent. We have seen that machines, when we give enough examples, they can learn from those examples and they can do the job on their own. So what if we show a lot of these historical contracts and say 100+ contracts, and we isolate these clauses, individual clauses, and we label the clauses manually, because we have to first teach the AI. So we say each clause belongs to one of these 11 categories. Does this clause belong to dispute resolution? Is it a scope item, or is it terms and conditions? I identify the category, and I also label the criticality. Is this clause critical or non-critical? In this case, critical could mean anything which needs human review, because I'm going to let the algorithm do the first pass, identify those alerts, and then I can review that and have a person do it. And then so that is a starting step. Once I show more examples, because from 100, if I move to thousands of documents and tens of thousands of clauses, then the algorithm will get even smarter. Then I can reduce the extent of manual intervention needed. So that way we can improve the algorithm and train it. So here's what it looks like. So in this case, this solution, it has an interface, and any contract which is uploaded, once this training has been done, the algorithm automatically splits the document into individual clauses. And then it runs, it scans through all of that, and it does this classification. It automatically says that in the document that you uploaded, there are 34 clauses which fall into confidentiality. 35 which fall into finance. It identifies all of those. And it says there are, say, 28 critical clauses. I've filtered for something. 28 critical clauses I've filtered for legal. So there are 28 critical clauses in legal and 3 non-critical clauses. So with this filter, now it shows me this. So if you look at it, this has highlighted the names of the companies, because here the objective was to flag anything which needs a human review, the name of the company, the jurisdiction, any penalty clause, financial numbers, we want to highlight it. Whereas the third one, this is standard legalese. So this is not highlighted. So this way, a contract review solution can save a lot of time. And you need to have what is called the human in the loop, because the intent is not to replace entire human effort, but to automate wherever you can train a machine, so that 80%, 90% of it you train and pass it to the AI, and then you have some experts coming in and validating for the rest of it, or for some really tricky critical contracts. So this is how AI can simplify the process, and this is something which can be very, very useful for organizations. So that was the final example case study. And before we move on to the section, I wanted to share something. So AI, we have seen AI and machine learning, how smart they are, but they're not really smart in all the spaces. This is again a hype. People assume that just because AI can do a lot of things, image recognition, and do a lot of predictions, it understands it. The challenge with AI is, behind the scenes, it doesn't have any understanding. It is really a pattern spotting machine. When you have billions of data points, a human cannot possibly go through all of it. A machine can go through it in a jiffy, and it will be able to identify some patterns which probably no human can identify. But once it identifies the patterns and it learns from those examples, it doesn't mean that it understands the meaning of it. So which is why when people talk about AI, immediately what they picture is like a robot, Boston Dynamics robot like this, which can move, it can do backflips, and it is amazing, right? These forwards are terrifying and fun to watch too. But in the real world, robots are not like this. They are clumsy, they're not able to hold stuff, and when they fall down, they're not able to get back up. So that is the current state. So a clear difference between these. So there are some which are in research labs, in carefully controlled conditions they work, but AI is not that smart yet. So which is why AI taking over the world is not really something that we need to fear about, at least for now. Some more details, right? When we talked about prediction and classifications. So when I show this picture to all of you, if I ask you what is there in these pictures, probably all of you would say this is a squirrel and this is a dragonfly. This is pretty obvious. But when you show this to a machine, it doesn't get it right. This one, the left-hand side, this picture, it thinks it's a sea lion, and it is 99% confident that it is a sea lion. Whereas on the right-hand side, it mistakes the dragonfly for a manhole cover. Again, it is very, very confident, 99% confident. So it could be the angle in which the squirrel is standing, for instance, or the background texture. There could be a number of factors. When you don't have enough variety of examples, because AI learns from examples. If you don't have good examples, enough volume of examples, and enough variety of examples, AI will fall short. So that is something that everyone must understand, and keep in mind that when you have some really mission critical applications, or if the tolerance for failure is very low, you need to watch out for it. And finally, AI can also be fooled easily. This picture, when it was shown to AI, it understood, it was able to recognize that it is a pig. No issues there. But when you inject some noise into the picture, into the same picture, then what happens? The AI is fooled into thinking that it's an airliner. To the human eye, the right picture on the left looks the same, but this noise which is injected, the AI doesn't get it right. It gets confused. It's called adversarial attack. And imagine this could be really risky. If you have a self-driving car, hackers could take over, and when it sees a stop sign, it could be actually made to go faster. So these are some real challenges in AI, which is why it needs a lot of discussion and it needs careful implementation. So there are some situations where AI is just not right. As a practitioner, I need to tell both sides of the picture, right? So there are 5 situations specifically where you should not use AI. Number 1, when simpler solutions exist. For example, if you talk about forecasting, regression forecasting, ARIMA techniques might be pretty effective in many scenarios. There, you don't have to force fit AI. If your accuracy and stability is good, go for simpler solutions, statistics or machine learning. You don't need AI. Number two, when you don't have enough data, if all you have is 10 to 15 data points, you really can't use AI. Third scenario is where AI is still an experimentation. We looked at some examples where AI fails terribly.
Yes.
Yeah. Yeah. So, is there a question?
Was that a question?
What do you want me?
I need to go for a walk. So I'm going to compromise with her. She wants to wait until 7:30, but I'm worried that she's going to get involved in her thing.
What thing?
She's on her stupid.
Who do I need to mute?
PJ. It's PJ.
PJ.
Okay.
Oh. PJ figured it out.
Okay.
All right, good.
Yeah.
Go ahead.
So back to situations where you should not invest in AI. We need to be careful with Zoom as well at times. So third situation is where AI is still an experimentation. We looked at examples where it is doing good in labs, but not ready for the real world. Number four, when the costs outweigh the benefits. Mark spoke about it. When you need to prepare a lot of training data, there's a lot of cost in training the people and managing the change. Probably AI is not the right solution today. Maybe in the future, but not today. And finally, anything that where users need empathy and understanding. We have seen AI doesn't have that quality yet. So probably you're better off giving those tasks to humans, or at least keeping humans to a greater extent involved in that. So those are situations that brings us to the end of the section, the industry applications. So if there are any questions, you can.
So just without, so sorry to interrupt. I just wanted to chime in here because of all the four or five different use cases that Ganesh described, right? I think especially the last one is an intriguing one, right? It's about the smart contracts. It's about ability of AI to read through contracts, to classify different classes, look at potential risk, that type of stuff. And I think that may be a very good application for those in procurement. So my curiosity is to really learn from you. Is any of you using anything similar in your organizations where every contract you make with every vendor is not going to legal, but it actually is read by a machine? And then when it is, when there is sufficient risk involved, then it's flagged up to an attorney, what have you. What do you do? Do any of you have any type of interaction there with in terms of your contracting? Because I know some of you procurement experts, probably read like 10 contracts a day. Anyone exposed to such type of AI in your work today?
Nice to have. I do contracts every day, and
I know.
I don't have that.
But
I have to do the legal and
coming. I'm pretty sure it's coming. So because
nice.
we do the same thing. We also read contracts. I think it'll be helpful to have such type of a classification.
Are you familiar with the program called Concise? It gleans through hundreds of contracts, seeking out specific clauses so it can direct a form of requirements / design analysis of what needs to be done for developing a quality assurance surveillance plan. We use it for the government, and it's been interesting how they've been able to pretty much take care of a great deal of our contract review simply, and then we're able to then figure out what specific main areas that we need to assure that we cover that the contract calls up. I would almost think that that's kind of have to be some sort of AI application. There's a number of algorithms that was used to run that program.
Okay, excellent.
Again, Concise. Have you ever heard it?
How do you spell it? Concise?
Concise.
Concise. Okay.
Government.
I don't know of it. I've heard myself. I've seen several. You get the cold call emails from all these people that say they have similar type stuff, but I don't know. I haven't done it yet. This is
Well,
great
next
info.
time you get a cold call or an email, just get hold of them and say, hey, we need a demo and we could make it an Apex PDM,
Yeah, exactly. They would probably love that.
Right, right. Okay, Ganesh, sorry to interrupt. You can move forward because I thought that was intriguing and that may
This
have.
is good. Yeah, this is good to get some reactions. So we'll move on to the final section. It'll take about 5 minutes, and please have your questions ready. We will spend more time on Q&A at the end of the section. So the final one is, how can you upskill in AI and ML? We've looked at what it is, what are the applications, and how can you get in and take a participate in the action, right? So that's the final section. Yeah. So we looked at this example. What does it take to build an application like this? Maybe it'll be good to get some reactions on what do you think are the skills and roles needed to build an AI or a machine learning solution. Can you type into the chat window, or maybe you can unmute and speak? Curious to hear some reactions. What roles and skills do you think are needed in AI machine learning? Okay, so this was the upcoming poll. Yeah, but this also is good to trigger now. The poll question is, which of these roles do you think is relevant for you, having looked at this? And by the way, the next slide will talk about these different roles. So probably maybe we can launch this poll again in a bit, Ken?
Sure. Do you want me to just kill it and redo it? Okay. Yeah. Sorry about that.
No, that's okay. That's okay. This was
we'll redo it again.
Planned.
Yeah.
So okay. Let me go ahead. So there are 5 roles and skills you need to create an AI solution, like an AI application. When people talk about AI, the common misconception is they only plan for the algorithm. They just think about coding the algorithm. AI is a lot more than algorithm creation. So number one, you need to start with the domain. So in the example we looked at, the cargo delay example, so we had to understand the business workflow. What are the influencing factors? We looked at the shift and several other items which we started off with, right? So someone has to start with that, look at the different influencing factors and what is relevant. Even choosing the right problem in the project needs domain expertise. So that's why that is a crucial skill needed in this mix. Number 2, in this case, we looked at impact analysis, clustering techniques for the analytics part. And we had a nice presentable aesthetic UI, user experience, and the front end, the charts that you saw, they were easy to understand. So it needs design skills. And fourth one, it needs development programming skills to package all of it together and make it work like an application. And finally, project management to coordinate, piece it all together. And importantly, take care of change management. Once the AI solution is built, how do you take care of change management and roll it out within the organization? So here are the 5 roles, and these are the titles which people use within the industry. Domain, people call it the data translator or analytics translator. These are people who have strong domain knowledge and basically business analysis expert. They can do solutioning and can bridge they call data translators because they act as a bridge between the business teams and the technical teams. Imagine business analysts who also have good data understanding. Number 2 is analytics, data scientists. This is an obvious one. Mastery of statistics, machine learning, AI techniques, ability to interpret insights, not just find the insights, but also interpret it. And then scripting skills. If someone has programming skills, great, but otherwise basic scripting skills, because many of the tools like R need that. Design, information designer. Information design is a discipline which visualization, dashboards, all of it fall under. So how do you present information? So they should understand there are courses for this, and there's a separate masters in design, specifically on information design. So it calls for user-centered design, understanding visual aspects of design, interface design and all. Finally, development, programming is ML engineer, machine learning engineer is a popular terminology. So a strong understanding of software engineering, ability to do front and back end coding, connect to the data pipelines, and all of these are needed here. Project management, the role is called data science manager. So very good project management skills. Additionally, the person should also have some business analysis solutioning skills, because the managers here don't just manage the timelines, but they need to take care of the change management and checking whether the idea is executed in the right spirit. So that way, these are the 5 roles and skills. And for someone who's looking at making a career here, or there are many people who ask me, like, after 10 years of experience, 15 years of experience, they want to switch into machine learning or AI. So typically, if you look at the audience here, supply chain and experts in this domain, I would say most of the people might fall into the first category, come with heavy domain expertise. The data translator or analytics translator role could be one, which you would be able to play, because you have the domain background. If you understand data and an overview, this role doesn't have to be experts in AI techniques or doesn't need coding. So you'll be able to pick up these other business analysis, solutioning skills, and basic data skills. You'll be able to play that role. Or could be, a lot of people get into project management, like a data science manager role. This again doesn't need some of those technical skills, but an overview of all of these different areas is required. So these 2 could be potential roles which people could take up. And there are others who might not be aspiring any of these roles. They just might want to get familiar with machine learning and AI, because as part of their organization, their current role, they just want to be informed about it, which is a 6th category, which is fine as well. So this is where we wanted to trigger the poll C, to find out, for this audience, are any of these 5 roles of interest to you, or are you looking for just topping up your existing role? You're not looking at switching, just understanding of machine learning and AI. Is that of interest? We'll give it a few seconds. The next, the final slide talks about how to pick up these basic skills and some places where you can go in and find material or courses to do. So we'll conclude with that one. If we have enough responses, we can close the poll. So these are, like, it's good to know about these roles, and you can probably spend more time in terms of understanding, and there's a lot of material available on the net on these. Okay, majority of people are looking at stopping up the skills and they're continuing the same role. I think other 2 popular categories are data scientist. Okay, that's interesting. A lot of people aspire this, and data science manager, which is fine. I think data translator is not very popular. I was thinking probably this might be popular too. Okay, great. So let's move on to the final one in terms of how do you build these skills, right? So, and what are the basic skills that you need when you talk about making a career here? So you should start with data literacy. What does data literacy even mean? An ability to read, write, and converse in data. If you have data in the form of tables, charts, or any form of presentation, are you able to understand and make sense of the numbers there in any form the number is presented? And if you have to communicate the information to someone, can you pick up the relevant insights and communicate it by crafting, say, stories, or conversing with the key findings from the data? So that's what data literacy is, and this is again an upcoming discipline. A lot of people are working on this, and there's like leaders in organizations are planning to get their teams, like every user within the organization, to be data literate. So that way, there's a huge interest in data literacy. After that, you should learn how to identify insights. It could be, depending on the extent of techniques that you want to use. It could be very simple pivot tables in Excel that is needed. Whereas people who want to be a little more adventurous, if you want to get into, say, the next level of techniques, say formulae or statistics techniques, or even some basic machine learning techniques. If you want to get into that, depending on how much you want to learn in terms of the analytic techniques, you can experiment with that. But the key point here is to identify the insights. And then the next one is to present the insights. Once you've identified something very unusual with your data, how do you communicate it? How do you tell stories from it? Like we looked at, it could be just in PowerPoint. How do you craft a narrative and convince someone? And finally, stay in touch by looking at the business applications, there's a lot of interesting applications of ML AI, particularly in supply chain. Stay in touch with it, understand what are the new developments. And when you build these things, how do you go about achieving it? Right? So it could be online certifications. Coursera has a lot of great free courses and other courses which you can audit for free as well. And there are several academic programs. Almost every school has their own data science or analytics programs. So these could be starting points depending on whether you want to do it at your own pace or do it with a cohort with a university. Number two, once you learn that, apply these somewhere on your projects. Even there's no need for it, try to apply it at work or create your own hobbies, personal projects. A lot of people miss to do that. What happens is they complete a program. After 6 months, they're back to square one. So you'll have to apply these skills. And there are a lot of open data projects available. You can practice it there. Join communities. There are very active communities where people come and discuss data. They talk about storytelling. So you can collaborate and stay in touch there. And finally, maintain a public portfolio, showcase your skills, whatever you try out. You could either write articles on Medium, and there are several great publications, or it could be just a portfolio showcasing it on LinkedIn or other social platforms. So that way you can maintain this on an ongoing basis. And these are ways that you can slowly make, and depending on the pace that you want to take it, you can slowly move ahead. Any questions? Mark, you want to add something here?
No, I think, make sure that I'm not on mute. Okay, yeah. So, I mean, I know many of us are, supply chain professionals, right? In fact, I attended a seminar about, I think about a couple of weeks ago. People kind of wondering and worried about their careers, especially given the pandemic had really kind of caused an upheaval, right? But essentially upskilling with AI, not just like becoming a data scientist or a data engineer, but really understanding what AI is and how it can help you. I think that would be a very good path to take in terms of reinvigorating your career. Because at the end of the day, people don't want to be afraid of data, right? Even if it is, a question of like, whether I want to be an engineer, whether I want to be a data scientist, but ability to be familiar with data, ability to analyze data, and even Excel is good too, right? Because the one exposure that most supply chain professionals get would be some type of a visualization program that they should be very familiar with, being able to manipulate numbers, being able to extract decisionable insights, right? So some of you probably already are using it, programs like Tableau or Power BI. Power BI is probably the most common tool because it's also inexpensive, right? You can get like a simple Power BI license almost for free from Microsoft, right? So I think, creating decisionable insights through data is going to be very powerful. And at the end of the day, it is going to be an enabler for anything that you do, and particularly for supply chain, because I know we live by the numbers, right? So I would say, as Ganesh was saying, like, even taking a little course, like auditing a course, just to understand what it is that we can learn from, data insights will go a long way in terms of helping your career.
Thanks, Mark. As Andrew Ng, pioneer in AI, says, AI is the new electricity. It is the future. Irrespective of whether people want to be very actively involved in it or not, AI is going to impact all of our lives and it's going to impact the future. So it's good to learn about it and see what is the coming change. Thank you.
Very good. Okay, so I think we should probably just kind of like have an open discussion, any type of questions that you have, particularly on AI, either in terms of upskilling, reskilling your career, or in terms of, any of the use cases that we talked about, or maybe some of you have any specific use cases that are already using either AI or machine learning. We would love to hear.
We did have one comment that said from Ram, that important skills for this is coding and math, and obviously domain knowledge. So that was a good comment from Ram.
Thank you.
I just want to say that was a very well done presentation. A lot of intimate details there that I think we all could take back and try to digest. Hopefully, we can use it and outcome. Some of the stuff I see that's happening in the Pratt really to a great detail and from the level of work that they do. A lot of algorithms, a lot of AI that they use to develop the engine software. I have to say, probably Sikorsky is the same boat. Looking to capitalize on those fears, I read a number of books. Michio Kaku's Physics of the Future and all his good stuff. Money may push us in a situation where jobs will be lost. And as jobs become more, money that could be saved with automating versus having people work. And I think there's it'd be out of the control of the AI scientists, more into the boardroom of what money they can make for their creditors and investors. And I think in the long run, we stand to run a big risk of financial problems on the road. I can't help to think that, it may be a good thing. Maybe we won't have to work and we sit around and watch TV all day like we're doing now. Or it may put us in a difficult situation. Maybe not in our lifetime, but looking down the road for kids and grandchildren. But fears are there, my friend. I don't know if you can squash them. I think you try to do a good job, but I think you're still there. That's my input. Again, great work.
Yep. Great comments, Larry. Just one thought there in terms of the jobs lost versus the effort saved, and people also talk about new jobs which will be created. So I strongly believe that it's going to be asymmetric. The kind of jobs which will be created in 5 years, 10 years from now will be very, very new, which we can't even anticipate today. The only hope is that we create enough jobs, or probably more than what would be taken up or will be made irrelevant by AI. And we've seen this last 100 years with every revolution we've seen, that with every technology innovation, there always has been an asymmetry in terms of the kind of roles which have come about. So there was a recent report, like 2050 jobs or so, like what jobs we'll likely see in 20 to 30 years. It had a lot of completely unexpected, like mind-blowing kind of titles and roles. So maybe we will see roles like that emerge. But you're right, yeah. So there's still some fear for the short term. And importantly, even if there are new jobs going to be created, the skills needed and the retraining needed for that, that needs attention. It's not going to be easy.
Absolutely, absolutely. Because I think the retraining, and there has to be a lot of push and investment that has to happen in terms of retraining, right? Absolutely. I think that's because it is definitely going to create more jobs. Anytime when there is a fear of losing jobs, especially when we experience any new technology, I just tell myself that, maybe we should just watch any of the movies from the 80s, right? If you go back and look at any of the movies from the 80s, you would see typing pools. Do you remember typing pools? Like, you will have like an entire floor of people typing. It'll be like, 200 people typing, right? And those jobs disappeared, right? Completely disappeared. But did they like completely lose their life? I don't really think so. They reinvented themselves and they are in the workforce, right? So it's just, I think technology is going to change every 5-10 years. Things are going to change. But definitely people have to be, reskilled, and they have to be up for it. Because, the good thing is it's not about government making investment. It's just, if you think about it, most of the knowledge is free. All you need is a computer. And, the courses that Ganesh was referring to in Coursera or edX, all of these courses are really free unless you want to get an audit or a certificate. So,
yep.
But good comment, good comment. Any other questions, comments?
There's a comment from Ram. He says we used to do customer sentiment analytics, invoices, dispute clearance, predicting ETA and lead times. Okay. Customer sentiment, all of these
Done through AI.
machine learning. Yeah. Invoices, dispute clearance. That's interesting. Yeah, maybe Ram, if you want to talk a little bit more about it, if you're comfortable sharing, otherwise that's fine. But all of these look interesting.
Yeah, sure, Ganesh. Actually, we used to do an text analytics, right? But actually, I'm not involved, but I was part of the domain team, and my data science team used to do an text analytics and then find out the sentiment of customers' comment, and then we used to find the top customers, and then that will help our customer team, as customer service team, to clear the disputes. So these are one of the best thing our disputes teams are using, right? Maybe we are just trying out ML in that.
Okay.
Yeah.
Interesting. Yeah.
Yeah. Thank you.
Thanks, Ram.
Thanks, Ganesh. It was a very interesting session. Thanks, Mark.
Thank you.
Any more questions, folks? This was a great presentation. Boy, I really want to say thanks to Mark and Ganesh. Wonderful job. Who's going to send the presentation? As soon as you send it, we will get it posted up on the website. Our website, Apex Massachusetts Minutemen. I think New Haven's going to post it too.
Yeah, I'll share it with you, Ken. And thanks
Excellent.
for thanks to Mark, and thanks to you for all the coordination, and thanks to everyone for listening in.
Thank you.
And we do have another poll. This is the how you were satisfied with the meeting. I'm going to launch that. This is in progress, so if you have any thoughts on how to improve this last poll, just send them my way. I did put an email address somewhere here. Email thoughts and suggestions. So that would be great. And Jeff Locke, are you still out there?
Is
Mary
Jeff
Locke?
going to play his guitar?
He's got to close us out with the tune, but I don't know if he's still. Oh, he's on.
Just finishing
there.
up the poll here.
Say again.
Just finishing up the poll.
Oh yeah. Oh yeah. No, it's too soon to. Yeah. That's great.
Okay, there you go.
A week ago, I didn't even know how to do a poll, and I just studied up, and now I've gone berserk. I'm
Now
a
you're
poll crazy man.
I think you've reached yourself, Ken.
Achieve Smeehood.
You're completely retooled and reinvigorated. How about that? Huh?
Got accused of being a Smee at work, and I said Schmo, not Smee.
We had almost 50% of registered people show up, so it's not too bad.
Good.
I'd like more, but
I hope, Ken, the technology of this virtual meeting across 3 or 4 states does not change or preclude us from meeting in person next year after the virus goes away, right?
oh yeah. Well, the best networking I ever had was in person. I mean, I met people that I still know today. People that are in pretty high positions now, and you really, it's hard to talk to a person one-on-one unless you put them in a breakout room.
Right.
With a virtual meeting. So clearly in person is definitely the best networking, but can't do it yet. Soon, hopefully.
Very good. So Jeff, are you going to play a tune for us to finish up the holiday network party?
Oh, holiday tunes. And sorry it ran over, folks, but
yeah,
but it was so interesting.
Quick one.
Yeah. Let me
How's that?
awesome.
I think that was written up here, actually. You know that? I think that was written in. I forget. No, maybe that wasn't it. It was one of the tunes. A couple of tunes were written up here in New England by a guy in Somerville.
That is awesome. That is awesome. Nice work.
Oh, good.
I love it. Hey, is John Sawyer still on? Nope. All right, I had a question on polls.
Yeah.
Boy, Jeff, that was great. Thank you so much. You know, you have to come to every PDM because you're the official theme master. So
Oh, gosh, I better start practicing.
you gotta. You and Eddie Van Halen. Here we go.
The problem, work gets in the way, gets in the way of my playing, you know?
Well, you know, your people at work should know you're working at home, so they should have you do these tunes for all the work meetings
God,
too.
yeah.
Very good. Thank you, Jeff. So
All right.
Ken,
Thanks,
you
everyone.
Thank you.
and posting it on YouTube, right, Ken?
Yeah. Oh, yeah. Well, yeah. On our site,
Okay.
you'll see through the link eventually. So.
On behalf of the
Bye.
Bedford
Thank you
chapter,
very
I
much.
mean, the
Have a good
North Shore
holiday,
chapter,
everyone.
thanks a lot.
Yeah. Have a good holiday.
Thank you, guys.
Thanks, everybody. Have a great
Thank
holiday.
you.
Okay.
Bye.
You too.
Bye.
Yeah.
That was very good, Mark Gaines. Very nice.
Thank you, Karen. Thank
Yeah,
you.
that was awesome.
Take care.
Yeah. Have a good evening. All right, Ganesh, we'll talk offline.
Yep.
Thank you very much. Thanks for the time into it. It was a great presentation. So I think it was fantastic.
Likewise. Thank you, Mark.
All right.
How's that?
Oh, wow. Ken, you are awesome always. Where is it from? Huh? I want to.
Anyone can download that. It's from Microsoft Store, and it is called Animated Snowfall Free from the Microsoft Store, and I put it on one monitor when I'm working. You can have music, or you can kill the music volume completely, so you're not listening to music while you're working. That's good if you have more than one monitor. So
it looks really festive now. Probably in January it will feel very cold.
Yeah, it does look cold, but it's festive. We like festive.
Yeah.
Yeah. Great. All right. So there we go. Exciting stuff.
Yeah.
So hopefully everyone likes it, and we will talk soon, people.
Okay.
Thank you.
Excellent. So just to kind of when you collate the survey, I think let's discuss. And then do you have any comments that came through chat today? I think I saw Jim sending some comment today, but yeah, Jim would. So
it says, well, the only comment, we only had 2 comments.
Like somebody was disciplining a kid in the middle.
Yeah.
PJ.
Yeah, it says turn off presentation so we can see each other again. That was good. And then Ganesh did shut it off then.
Yeah.
And then let's see. Thanks for great presentation. Somebody wrote, we used to do customer sentiment analytics, invoices, dispute clearing, predicting, etc.
Yeah.
And lead times. And
so
then yay, Jeff.
The audience was good too, right?
Say again?
Overall, the audience was good, I thought, right? It's the turnout, like I think we had 50, right? We had 50.
Well, one person wrote, tried to put very satisfied, but could not submit because they must have missed the cutoff on the time.
Very what?
It looks like Kendarati tried to submit very satisfied, but couldn't submit because the time ran out. And then great way to close out the session. Thanks, Jeff. That was from Ganesh himself. And then Michelle Blake said, you have to click one of the email boxes, even if you aren't going to email comments. I don't know what that means.
Oh, yeah, that's because the people don't want to just like answer one of those questions. But if they don't pick it, then they won't be able to hit submit. That's what she means. Yeah.
Cool. Right. I usually do a screenshot.
And
then Sophie says thank you. And George says thank you to everyone. Have a good one.
Who is Sophie? Sophia. Is that a student or?
I don't know. And so there you go. So it was pretty exciting.
Yeah, it's a good topic. Is this is this a better turnout than the last PDM?
Yes.
How many was the last time?
I don't remember the number, but there was no way we had 50 people actually logging in. I think 59
I think you should stop
registered.
Recording. Can stop the recording.
Say again?
Stop the recording.
Oh yeah. Good point. Let me see. Hit stop.
Because you have to edit out the last